Hi, and welcome to my video on Part 7, Evaluate Trig Expressions with Radians. Find the exact value of each. I'm going to go through a series of problems, explain how to evaluate with a radian. Notice a radian, pi over 6 is a radian, pi over 3 is a radian, and the radiant that I'm going to is in terms of pi. So, pi over 6, let's look at pi over 6. Pi over 6 is 180 divided by 6, so that's 30. So that's 4 sine 30. And pi over 3 is 180 divided by 3 is a 60. So what I do, I convert the radians to degrees, because it's easier to work in degrees. So 30 degrees, let's draw a rotation on a circle of 30 degrees. There's the 30-degree rotation, and the terminal arm goes out through. You drop perpendicular to the x-axis. There's your 30 degrees. There's your 60. Notice the rotation is 30, so the central angle is 30. And besides, pi over 6, your pi, your denominator, tells you divide into pi what your reference angle is, 30. So that's a 1, and that's a half. Opposite 60 is root 3 over 2. And so the sine of 30, sine is opposite of 30 is a half. Sine is a half. Now we'll work out the tan of 60. So let's look at the 60-degree rotation. There it is. 60-degree rotation is up here. And you drop, the terminal arm goes out through the rotation, perpendicular to the x-axis. Again, pi over 3, so the reference angle is going to be 60. Let's see. The rotation is 60, so the central angle is 60. This angle is 30, and the reference angle is 60. Pi over 3, 60. So this is a 1. Opposite 30 is a half. Opposite 60 is root 3 over 2. And tan is the y over the x. So the y is root 3 over 2, and the x is a half. So that becomes root 3 over 2 times 2 over 1. 2's cancel, and I get a root 3. So the tan of 60 is root 3. Notice the exact value. Now, we have to use PEMDAS to simplify this, so we multiply these first before we add. So 2 into 4 goes 2, so that's a 2. Root 3 times root 3 is root 9, which is 3. And we add, and we'll get a 5. So, simplify 1. So hopefully, and don't forget, you can pause the video and work these out first if you wish. They really tell if you know what you're doing. Do pause it and work on it to see if you have it right. So number 2, cos squared of a negative 5 pi over 4 plus the sine squared of 4 pi over 3. So let's look at 5 pi over 4. So that's 5 times 180 in degrees. So that's 4 into 180 is 45. So that's a negative 225. So I got the cos squared of a negative 225. Again, what I do, I change it to radians to degrees. It's easier to handle. Now I have 4 pi over 3. And again, notice that pi over 3 is a 60. Let's see. Pi is 180 divided by 3. 3 and 180 is 60. So that's a 240. So that's 240 degrees. Remember, pi over 3 is 60. So the reference angle is going to be 60 when I plot the 240. The reference angle here is going to be 45 when I plot the negative 125. So here we go. Do the rotation of a negative we're doing negative 225, so it's right here. And up here, right to there. And notice the reference angle is 45, so when I draw my terminal arm, perpendicular to the x-axis, this is a negative 225, 180, so that's a 45 right there, reference angle 45, right? Pi over 4 is 45. This is a 45, 1. So this is root 2 over 2. This one is root 2 over 2, opposite the 45's isosceles triangle. Y is positive, x is negative. And we have the cos, and the square goes on the bracket. So the cos is the x, which is a negative root 2 over 2, plus the sine squared. So let's plot the 240. Rotation. 240 degrees is a 90, 180, and 180 and how much more? Well, 180, that gives us a 60. So this is a 60 degree arc here. Terminal arm goes out through, perpendicular goes to the x-axis. And this arc is 60, because remember now this is 180, and 60 is 240, so the reference angle is 60, or central angle is 60. This is a 30. And look back, pi over 3 is a 60. 60, perfect. Opposite 30 is a half. Opposite 60 is root 3 over 2. And in the third quadrant, the x is negative, and the y is negative. So the sine is the y, and the y is negative root 3 over 2. So we have the cos and sine simplified. Now we're going to square them. So it's a negative root 2 over 2 times negative root 2 over 2. Add on. Square negative root 3 over 2 times negative root 3 over 2. Negative times negative is positive. Root 2 times root 2 is 2. 2 times 2 is 4. Negative times the negative is a positive. Root 3 times root 3 is 3. 2 times 2 is 4. Two fractions have the same denominator of 4, so we add. 2 plus 3 is 5. So 5 over 4 is the answer when we evaluate that expression. Again, notice I'm changing my radians to degrees first and then working it out. I'm not using a calculator, because remember, sometimes when you do SATs or stats or get in university, you need to use the pencil more than the calculator. So here we go. 12 cosecant of 5 pi over 6, secant of 3 pi over 4, and a cot of 2 pi over 3. Notice there's a multiplication understood to be between these. There's no addition, there's subtraction or division. So that we're multiplying. So this is 12 cot. So let's do 5 pi over 6. Notice this is pi is 180, so that's a 30 degrees. So that works out to be a 150. Secant, and we have a 3 pi over 4. Pi over 4 is 45. 180 divided by 4 is 45. So that works out to be 135 degrees. So that's 135. And we're doing the cot of 2 pi over 3. Pi over 3, 180 divided by 3 is a 60. So that's 120 degrees. So we got them all changed. Again, degrees is easier to do. So what I'm going to do is work out the cosecant, work out the secant, and work out the cos. Put them in those brackets. Here we go. Let's do 150 first. Rotate 150. Start here, and that's 90. And we take off the 90. We get a 60 left. So we're gone over here 60 more. There it is. There's the 150. That means there's a 30 left. We draw the terminal arm perpendicular to the x-axis. And again, we said pi over 6. Pi over 6 is a 30. So, right, we know we have a 30 reference. This is a 60. Opposite 30 is a half. Opposite 60 is root 3 over 2. And the hypotenuse is 1, radius is 1. Y is positive, x is negative. So the cosecant is 1 over the sine of 150. So that's the sine of 150 is the sine of the 30, and sine is a half. So that's 1 times 2 over 1, or 2. So that works out to be a 2. So notice I did the work here rather than do the work in here. I work it out and then put the final answer in. The secant of 135. Let's draw 135. So 135 is a 90. Take off the 90 and we get 45 left. So we go in here 45 degrees. So there's the 135. So this arc right here is 45. Terminal arm goes out perpendicular to the x-axis. So this arc and the central angle are the same. So the reference angle is 45. This angle is 45, 45, 45, 90. 1. The two angles are the same, so the two sides are the same. So the sides are x is root 2 over 2, but it's negative. The y is root 2 over 2, but it's positive. And secant is the reciprocal of cos. So it's the cos of 135 degrees. And the cos is the x, which is 1 over negative root 2 over 2. So that's reciprocal is a negative 2 over root 2 times root 2 over root 2. So it's negative 2 root 2 over root 2 times root 2 is 2. So that comes out to be negative root 2. And there it is up there, negative root 2. And we have to do 120. So let's rotate 120 degrees. And 120 is 90. Right there. 120. And that means there's 180 here. So that means this is a 60 from here to here, because 60 and 120 is 180. Terminal arm goes out perpendicular to the x-axis. So the arc is 60, so the central angle is 60, so the reference angle is 60. This angle is 30. And check, pi over 3, 60. Perfect. 30, opposite 30 is a half. Opposite 60 is root 3 over 2. The y is positive and the x is negative. And cos is the x, which is a negative a half. Okay. Oh, I wrote down cos. Look, this is a cot. I just noticed. This is a cot. So I had to do the cot of 120. So cot of 120, cot is the x over the y. So that's a negative a half divided by root 3 over 2. So that's negative a half times 2 over root 3. So that gives us, go up here, that the 2's cancel, negative 1 over root 3 times root 3 over root 3, negative root 3 over 3. Negative root 3, almost made an error. Just had to be careful. Just had to be careful. Just move that over a bit so you can see it there, because I was writing and not looking at. So I have x over y, negative a half over root 3 over 2. So that's a negative a half times the reciprocal, 2 over root 3, 2's cancel. And I get, notice, I get negative 1 over root 3 times root 3 over root 3, because you can't have a radical in the bottom in your denominator. So that gives me negative root 3 over 3. Okay, now we got to simplify all multiplications. So we got a fraction, so cancel if we can. 3 into 3 once, 3 into 12 is 4. So we got 4 times 2 is 8. Negative times a negative is a positive. Root 2 times root 3 is root 6. So we have it simplified. Fully done. And again, apologize for that little error there. I wasn't watching how far I was moving off the screen there. But notice you draw the diagrams, you watch out for your reference angles to make sure you're right. And note I'm using 2 triangles. I'm using the special right triangles, the 30, 60, 90 right triangle and the 45, 45 right triangle that I've used in the previous units. So we're back again practicing them on the radians. So here we go. Let's do negative pi over 3. So that's 180 negative over 3. So that's a 60. We got a 7 pi over 6. So that's 7. Pi over 6 is a 30. So that's 210. And we have a pi over 4. And that's 180 divided by 4. So that's a 45. So that's the cos of negative pi over 3 is a negative 60 degrees. Tan of 7 pi over 6 is 210. And we got the sine of pi over 4. So that's the sine of 45. So let's work each of these out. There's a circle, rotation. We're doing a negative 60, so negative 60 is right here. Terminal arm goes out through, perpendicular to the x-axis. So if the arc is negative 60, the central angle is 60, which is the reference angle, but it's never negative. This is the 30. Opposite 30 is a half. Opposite 60 is root 3 over 2. The x is positive in quadrant 4, going to the right. The y is negative. And so the cos is the x, so I have 1/2. And this is the time, so I'll put this in brackets, and I'll work out the tan of 210. Here we go. So 210, rotation. 210 is a 90, 180, and that's 180, and we're 30 more into here. So there's the 210. Terminal arm, perpendicular to the x-axis. So this arc is 30. This central angle is a 30. This angle is 60. And let's see, pi over 6. 180 divided by 6 is 30. So there's your reference angle, perfect. Opposite 60 is root 3 over 2. Opposite 30 is a half. And the x is negative, and the y is negative, because the x is going to the left, the y is going down. With the radius of the circle 1, or the hypotenuse. So the tan is the y over the x. So the y is negative 1/2. The x is a negative root 3 over 2, and that gives us a negative 1/2 times negative 2 over root 3. And the 2's cancel. Negative times negative is positive, so I get a 1 over root 3 times root 3 over root 3. So I get root 3 over 3. So that's a root 3 over 3, because I fully simplified it. And we have to do the 45. Rotate the 45 right to here. Terminal arm, perpendicular to the x-axis. This angle is 45, then the central angle and the reference angle is 45. The other angle is 45, because it's 45, 45, 90 right triangle. And pi over 4, the reference angle is 45. Hypotenuse is 1. This leg is root 2 over 2, and this is root 2 over 2. This is the x, and this is the y. So the sine of 45 is the y, root 2 over 2. Y is root 2 over 2. Now we simplify. We use PEMDAS. We have to multiply these two first. PEMDAS. We have brackets are done. No exponents to deal with. We have to do the multiplication and division. But we got to multiply first these two. So that's root 3 over 6. And the tan is, right? The tan of 2 tan is positive, that's correct, minus, and I got, that's a root 6 times root 2 is root 12 over 2, so that's root 3 over 6 minus, the root of 12 is the root of 4 times 3, so square root of 4 is 2, so that's 2 root 3, so that's 2 root 3 over 2. Now I could cancel the 2's, but I need a common denominator for both of these. So that's a 6, common denominator 6, so I multiply by 3 over 3. So root 3 over 6, subtract 6 root 3 over 6, and the common denominator is 6, and so that's a 1 minus 6, that's a negative 5 root 3. Okay, fully done. Notice all explained out. A little bit work on radicals that's needed. And we have 2 more to do. Now, this is sine of pi over 2 cos of negative pi minus 2 times the cos of 3 pi over 2. So, pi over 2 is a 90. Cos is negative pi, so that's a negative 180. And the cos, pi over 2 is 90, so 3 90s is 270. So these are easy to change. But I need to draw a circle now, and I'll use that circle. So this point here is 1 comma 0. This point here is 0, 1. This one here is negative 1, 0. And this one here is 0, negative 1. Remember, the center of the circle is 0, 0. And the radius of the circle is 1. So, notice these 1, 0, x is 1, y is 0. Also over here, 180. X is negative 1, y is 0. And up and down here, the x is 0, and the y above is 1, below is negative 1. So the sine of 90 is right here. Sine is the y, so it's a 1. The negative 180 or negative 180 is right to here. And cos is the x, which is negative 1. Minus 2 and 270. Here's 0, 90, 180, 270 is here. Cos is the x, which is 0. So we have to multiply these first. So multiply these two and these two. So that's negative 1 minus 0, which is negative 1. Done. Now, I did a little extra question here. I did more rotation, made it bigger than 360. So 7 pi over 2. It's pi over 2 is a 90, so 7 times 90 is 7 nines are 63, so that's 330. The sine of 3 pi is 3 times 180, so that's the sine of 540. Now, the thing about 630, you could graph it, but you keep going around. But if you take 360 off, then you'll get a 270. So the cos of 630 is the same as the cos of 270. And if you got 540, So if you take 540, which is too much, you bring it down, you subtract 360, you will get 180. So these are smaller rotations. So if you go around 360, if you go 630, you will go 360 and 270 more. So by subtracting 360, you just have to rotate once on the circle. And the cos of 270 is right here. And cos is 0, because cos is the x. 180 rotation, 180 is right here. And the sine is the y, 0. So 0 plus 0 is 0. Oh, I mark a plus sign. 0. 0 plus 0 is 0. And we have it worked out. But I did larger rotations and I took off the 360. So if you put in your calculator the cos of 630, you will get 0. If you put the sine of 540, you'll get a 0 in your calculator. But if you break it down into what we call coterminal angles between heavy rotation, small, between 0 and 360, you take off 360 off each of these and you pick up these smaller ones. And they're the same. So the cos of 630 is the same as the cos of 270. The sine of 540 is the same as the sine of 180, because they end up at the same points on the unit circle. So that brings us to the end of this unit. If you like my unit, click the like button, subscribe button. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.